Good morning, children. Last class we have seen the expression for period of oscillation, acceleration due to gravity. We know what is meant by the acceleration due to gravity of a compound pendulum. G is equal to 4 pi square L by T square. Now, next we are going to see determination of G and K of compound pendulum. G means acceleration due to gravity and K means radius of gyration. The first point you have to know is that the time period increases enormously when the point of suspension approaches the center of gravity. The last class in the figure I have marked S and G. S is the point of suspension, G is the center of gravity. So we must determine the length of the simple pendulum. We have to choose different lengths of pendulum for which we have to calculate or we have to determine the period of oscillation. So at exactly center, that is I told you 1 meter long rod, at exactly 50 centimeter, the suspension and center of gravity are same. Here the period of oscillation will be very large. We already know the expression for period of oscillation. T is equal to 2 pi into root of K square plus L square by Lg. For a particular value of L, the time period is minimum. Minimum means at the center of gravity and the point of suspension is equal. The length L1 will be equal to L2 will be equal to Gt square by 4 pi square. But L1 plus L2 is equal to Gt square by 4 pi square. For a particular value of L, the time period is minimum. Therefore, when L1 equal to L2 equal to Gt square by 4 pi square. That is, I have squared this value, that's all. So I squared and made it a small change. But when we add these two, that is L1 plus L2 is equal to Gt square. Therefore, we can write this as T is equal to 2 pi into root of L1 plus L2 by G. L1 plus L2 by G. For a simple pendulum, L1 plus L2 is equal to L. Therefore, we can write T is equal to 2 pi into root of L by G. T into 2 pi is equal to 0. Therefore, we can write this as T square is equal to 4 pi square L by G. If you change this expression, you will get the expression for acceleration due to gravity. That is nothing but we have to change like this. Therefore, G is equal to 4 pi square L by, we can write small t square or capital T square. Both things are equal. Therefore, this will become as meter per second square. Because length is expressed in meter, time is expressed in second square, 4 pi square the constant, T square means second square. Therefore, we are getting G is equal to 4 pi square into L by 2 square meter per second. We also know that what is that? Now we are going to see the expression for radius of gyration. We are going to see the expression for radius of gyration. We know that T is equal to 2 pi into root of K square by L1 plus L1. You can take this into root divided by G. And we are taking K square by L1 is equal to L2. Therefore, K square is equal to L1 into, this is equal to L2 I told. Therefore, K square is equal to L1 into L2, or K is equal to root of L1 into L2, where K is known as the radius of gyration. So we know the expression for time period. T is equal to 2 pi root of K square by L1 plus L1 by G, where this is the length of the simple pendulum. Therefore, we are expression this has G. Therefore, we are taking K square by L1 equal to L2. Therefore, we get L2 plus L1. Therefore, K square is equal to L1 into L2. Therefore, K is equal to root of L1 into L2, where K is known as the radius. This is according to theory. But actually, in compound pendulum, how is that we are calculating the radius of gyration? It means we are taking a graph. So this is the x-axis. This is the x-axis, and this is the y-axis. Here I am taking the period of oscillation t. Here I am taking distance from one fixed end. Distance from one fixed end. So this I have to mark as so this will be your 50. So this will be your 55, 60, 65, 70, 75, 80, 85. This is your 90, 95, 100. Here it will be 45, 40, 35, 30, then 25, 20, 15, 10, 5. So here I will get a graph. This is period of oscillation T. Here I will get a graph like this, and here I will get a graph like this, and this will be touching 50, 55, 60. Here will be touching this point, and here will be touching this point. So we have to calculate the difference. So actually it will be this will be 55, 50. So the difference, this is point P and this is point Q. So this point is P. Therefore you will find PQ is equal to 60. Therefore PQ by 2 is equal to K. That is equal to 60 by 2. That is equal to 30 centimeter. This we will find in the experimental part. So that 30 is known as the radius of gyration. Then we will draw one point like this. So we will mark this as A, B, C, this as D. Then you have to take the equivalent length of the simple pendulum is equal to AC plus BD by 2. So you know L value, then corresponding T value. Then we will find the acceleration due to gravity as G is equal to 4 square into L by T square. You find out the T corresponding T, square it. You know the length. Put the length is a constant, then you will find it. So in the experimental part is very easy. So in second year syllabus you have got simple pendulum. For a simple pendulum you are going to see what is the value of acceleration due to gravity, what is radius of gyration, what is the value of moment of inertia. So the moment of inertia is calculated using the formula I is equal to mk square by 2 kilogram meter square, because m is the mass of the compound pendulum that you have to determine by the viscous balance, and k is the radius of gyration. K is the radius of gyration. So these are the key data we have to solve. In a compound pendulum we have to find three data: 1, 2, 3. One is value of G. So that is equal to 4 pi square L by T square meter per second square. Then you have to find the value of radius of gyration. Radius of gyration K is equal to PQ by 2 from graph. PQ so many centimeter or meter, and third one is moment of inertia. Moment of inertia I is equal to mk square by 2 kilogram meter square. These are three things we are determining for a compound pendulum in the lab. What is the value of acceleration due to gravity, radius of gyration, and moment of inertia. Now sometimes they will ask in 5 marks. So now next we are going to see the main important thing. That main important thing is nothing but he will ask the points of suspension and oscillation are interchangeable. Points of suspension. Points of suspension and oscillation. Point of suspension and oscillation are interchangeable. A very, very important 5 mark question. For that, we have to draw this graph. As I told you, we have to draw this graph. Then we have to take this as a center. We have to draw these two types of graphs. And this centers. Actually, this you should draw in this form. Okay, this is your L1 point, this is your L2 point. Then you have to draw a line like this. This is your A, B, C, this is your D, this is your point E. Here is speed of oscillation T, distance from center of gravity. This is distance from center of gravity in centimeters. Like that you have to draw. In a bar pendulum, let the distance A from the center of gravity be L1 and the distance of C be L2. The time period when A is the point of suspension is T1 and the point of the suspension is T2. So this is the graph we have done. So we are calculating two lengths L1 and L2. The time period corresponding to L1 is T1. The time period corresponding to L2 is T2. So we are making 2 points. One point is A, another point is C. For C, A and B we are finding out the center point. That distance from the center to that is L1. Like this is L2. Here the time period T1. Here the time period is T2. Okay. Next we have to write these two time periods. So you have seen the graph. From the graph, next we have to write the time periods. Expression for time periods. The expression for time periods is nothing but T1 is equal to 2 pi into root of k square plus L1 square by L1g, or we can write this as 2 pi into root of k square by L1 plus L1 divided by g. T2 is equal to 2 pi into root of k square plus L2 square by L2g, or you can write this as 2 pi root of k square by L2 plus L2 divided by g. Here we know that what k square by L1 is equal to L2 and k square by L2 is equal to L1. Therefore, we have to add these two. So, when we add these two factors, what is that? K square by L1 plus L2 is equal to k square by L2 plus L1. So, these two factors will get cancelled. K square by L1, k square by L2 will get cancelled, and we get this is equal to L1 plus L2. L1 plus L2. Therefore, what T1 is equal to T2, because in the diagram which I draw before this, I told you from A the length is taken as L1, the time period is T1. From C, the length to the center of the gravity is taken as L2, the time period is T2. Therefore, when the lengths are equal, the time periods will be equal. So, we have to write at the last. What is the conclusion? Thus, the points of suspension and oscillation are interchangeable. First, if you are taking the point and the L1 has the point of suspension, then L2 will be the point of oscillation. If you are taking L1 to be the point of oscillation, L2 will be the point of suspension. So you remember this point. When we are teaching practicals, we will teach you and show you a demonstration or demo how we are taking the point of oscillation and how we are taking the point of suspension. So only in a compound pendulum we have to know that the center of suspension and center of oscillation are interchangeable. Center of suspension, center of oscillation, center of oscillation, center of suspension. If A is the point of suspension, C is the point of oscillation. If C is the point of suspension, then A is the point of oscillation. So in the compound pendulum, you have to remember there may be three types of questions. Either the questions may be of section B or the questions may be of section C. If there is in section C, he will tell you derive the expression for period of oscillation and determine acceleration due to gravity and radius of gyration. Otherwise 5 marks lendaga period of oscillation tali 5 questions 5 marks question, determination of G and K 5 mark question, center of suspension and center of oscillation are interchangeable 5 marks. So the important question for 5 marks is how is the suspension and oscillation are interchangeable. They will ask, for that you should be ready. Okay, thank you very much.